Hey, it's Mr. K doing a video for AP Physics C and 1. A lot of these are for both. There's going to be a definite difference in the future, but for now, yeah. In my haste, I forgot to just do a straight up adding vectors via components problem, and so this is going to be that. So a lot of times you're going to have forces that are affecting an object from many different directions. You're going to have to find out the resultant component of a vector, and all that means is that we're going to add all the vectors that make up that resultant together. And so we just did one with that projectile motion problem where we had the ending vector pointing down and to the right. To the right. And so we had to put those two vectors together, and we used Pythagorean theorem to do that. That was convenient because it only had a downwards and a sideways component to it. Here, we're going to add two vectors, and I'm going to show you exactly how to do that both graphically and algebraically, mathematically. So here we have vector A and we have vector B, let's call them, A and B. Vector A has length whatever and vector B has length whatever. A points up and to the right and B points down and to the right as well. And we're going to add these two things together. And so to do this, we can do it in multiple ways. One is going to be a little bit more accurate than the other, just because you're not always going to have a grid to work with. And so the algebraic way would be the more accurate one based on your values, whereas you can also add them graphically or visually, and that's what I'm going to do here right now. So if we were to add vector A to B, vector A goes up 1, 2, 3, 4, 5, and over 1, 2, 3. And so we would go 3, 4, 5, 1, 2, 3. Here's vector A, and I would use the tip-to-tail method. So the tip of this vector, here's vector A, would be attached to the tail of vector B, and I would start drawing vector B here. And vector B would go down to the right, and again my pen is dying and I don't know why, but that's okay. So here's vector B, and your resultant vector would go from the very beginning to the very end. And so again, a lot of times this isn't going to be what we do because we're not going to have to do it, but you would still need to know what we're talking about. So if we were to add those vectors together, the resulting vector, the resultant, would look like this blue one, starting from this point here, going over here, and it itself would have components that make it up. So it would go over 1, 2, 3, 4, 5, 6, and it would go up 2. So 1, 2, 3, 4, 5, 6, and then it would have a vertical piece to it. And so that's going to be your graphical method. You can always fall back to the graphical method. Another way to do this would be to separate vector A into its components of horizontal and vertical. And so we can go and look at the ijk vectors, or just the x and y vectors. We'll use blue for our horizontal here, and we would use red for our vertical. And what we said before was we have a horizontal piece that is 3 and a vertical piece that is 1, 2, 3, 4, 5. Switch over to red. Same thing for blue. The blue vector, or not blue, B. The B vector would have a -3, or just a 3 going down piece. I'm going to put -3 there for the moment. Really, it should just be 3 because the arrow shows you which way it's going. And then we have 3 also in the horizontal. So here we have another way to do it. We can take these vectors apart, just put them together graphically again by their pieces, and so I can have two pieces that go to the right that are both 3 and 3 again. So that would take care of our horizontals, 3 and 3 there. And then I could have my vertical 5, which would go 1, 2, 3, 4, 5 upwards, and then my 3 down, 1, 2, 3, and that would end me right here. And so once again, to finish this off, I would start from the very beginning and go to the very end, and if you notice, I get the exact same thing that I got up here whenever I did the full vectors themselves. And you might think, why is this even important? We apply this method a whole lot whenever we deal with forces, trying to figure out the resulting force, looking at displacements, putting those all together. So it's actually a pretty useful tool. Now, that's the graphical method. We could find out the totals on all sides. So we have a total of 2 there for this side. We had a total of 6 there. And then if we wanted to find out the hypotenuse, we can use Pythagorean theorem. And we could also find out the angle here. But I'm going to go ahead and go to the graphical or the algebraic method. And for that, we're going to say, hey, we're going to add vector A to vector B. Okay? And that's going to equal vector C. Let's call it C. So this is vector C here. And so, yeah, that might look stupid, but there's a point, because whenever you add these two vectors together, you need to add their components. You can only work with one dimension at a time. So if we were to add vector A to vector B, we would add AX plus BX, and then that would equal CX, and these are all vectors, so I'm going to draw the little hat on there. And then we also would add AY to BY, and we would get CY. Okay, and so we're making this into a mathematical, a written algebraic format, and so AX would be 3, BX would also be 3, and that would equal 6 for your C vector in the X direction, and that's exactly what we get here. AY would be 5, however BY would be 3 downwards, so -3, and that would equal 2. And so our vector C in the Y direction would only be 2 tall, and that's exactly what we've already done graphically. And so at the very end, we would simply redraw this with 1, 2, 3, 4, 5, 6 in the horizontal, and 1, 2 in the vertical, giving us the exact same result, I realize. And then your resultant would be this diagonal guy right here. Now you can do this with however many vectors you want to. I just want to do it with 2 because it's very tedious. Was that the word I was looking for before? I think that might have been. And then if you want to find that hypotenuse, let's go ahead and do the Pythagorean theorem. 6 squared, 36, plus 2 squared, 4, and then we need to square root the 40. And I get 6.3 to, I'll call it 6.33. 6.33 up here with your hypotenuse. I'm not sure what units we're using right now, so we're just going to go unitless. And then to be very appropriate, we need to find the angle. And like I said in previous videos, I want to use the values that don't rely on an additional calculation. So I want to use the 2 and the 6, and that would lead me to using inverse tangent, or tangent -1, arctangent. And then we need to put in the ratio of the sides here. The ratio is going to be opposite over adjacent, so 2 divided by 6, or a third. So inverse tangent, second tangent of 2 over 6 equals, and this is going to give me 18.43 or 44 degrees. 18.44 degrees will be what our angle is there, and we could say it is north of east, just to finish that off, and that's going to finish off this video as well. Just another supplemental video. It does take a little bit of practice, so make sure you are practicing along, homeworks and in class. All right.